Okay, so in this video I want to go through some specific exam questions just for the power of a lens formula. So I recommend just pausing the video, having a go before I go through it, and just have a read through. So it says, the diagram shows light rays from an object 25 centimeters in front of an eye. Okay, well that's going to be my object distance, u. So I'm just going to label or write down everything that I know for now. So u is 25 centimeters, converging to a point on the retina at the back of the eye. The eye has a depth of 2.4 centimeters. That's going to be my v. Now that might not be initially really obvious, but just from repetition of questions, this setup of having an object in front of the eye just repeats itself time and time again. So you'll start to see that we always want the image distance. So this distance here, the image distance is always going to be the distance between the lens of the eye and the retina, because images form on the retina. So that's the key point I'd like to get down actually. So we just say images form on the retina. Okay, so V is equal to 2.4 centimeters. Okay, calculate the optical power of the eye. Now for power questions, you need to always convert to meters. And that'll be clear why in a second. So we know that P is equal to 1 over F, but also 1 over F is equal to 1 over U plus 1 over V from our lens equation. So combining them, I get my power is equal to 1 over U plus 1 over V. Okay, now if I convert everything to meters, that's going to be 0.25 meters. Let's just move that out of the way. 0.25 meters. That'll be 0.024 meters. So replace the letters in my formula with numbers. I get 1 over 0.25 plus 1 over 0.024. Now if I put that in my calculator, I get 46 diopters. Okay, now the reason we need to convert everything to meters is because in order to get the correct units of diopters, our lengths or our distances need to first be in meters. Okay, so that's my final answer. The next question, so again, pause it and have a read through. But as you can see, it's exactly the same setup. We've even got the exact same diagram from before. So we've got the retina, front of an eye. Okay. Now let's go through and highlight some key things. It says a student with short sight cannot focus on objects further than 1.5 meters. Okay, well that's going to be my object distance, u. To view distance objects, it is determined that the combined power of her eye and her contact lens should be 41.7. Okay, so let's start thinking about what formulas we'll need. Well, combined power, so total power, PT, is going to be equal to power of lens 1 plus lens 2. But in this case, we have the power of the eye plus the power of the lens. Okay, so I'm just going to write these things as I go along. And it says my total power should be PT. So if you notice, as long as you label everything given in the question, then you need to work out your formula. So just label things as you go along. Then it says determine the power and type of lens. So we need to know the power and type of lens needed to correct her vision. Assume the equations, okay? Distance from eye to lens to retina, from eye lens to retina, sorry, is 2.4 centimeters. So that's V. And again, I'm going to convert to meters. But notice what I said. So again, just through repetition of questions, you can see my image distance is always going to be the distance from the eye lens to the retina, exactly like the previous question. So these things do repeat. Okay, so I'm just going to write down everything that I've been given. Okay, so now let's think about what the question's actually asking. It's telling us the total power, PT, should be 41.7. So let's write that. Okay, and then it says a student with short sight cannot focus on objects further than 1.5 meters. and we want an image formed at 2.4 centimeters. So what we can then do is work out the power of the eye, and then we need to work out the power of the lens, and this power of the lens should offset the power of the eye in order to achieve 41.7. Okay, so pi is going to be equal to 1 over the focal length of the eye, which is equal to 1 over u plus 1 over v from our lens equation. Now, we know that the object distance from the eye was 1.5 meters. So let's replace the letters with numbers. And the distance from the lens of the eye to the retina, remember the retina is where the image is formed, is 0.024 meters again. Okay? So working that out, we get that the power of the eye is equal to 42.3 diopters. Okay? So we've now got the power of the eye. So again, I'm just going to replace the letters in this formula with the numbers we've just worked out. So P total, 41.7 was given in the question, is equal to the power of the eye plus the power of the lens. Okay, so she's short-sighted, so her eyes are too powerful in order to give the required power that we need. Okay, so we need this lens to offset that. So let's minus 42.3 from both sides. Just rearranging, we get the power of the lens is equal to minus 0.63 diopters. Now this negative is really important. So first of all, our power is minus 0.63 diopters. And because it's negative, well, remember, P is equal to 1 over F. So if P is negative, well then in order for this to be true, we must have a negative focal length. Okay? So the type of lens, if we have a negative focal length, so negative focal length, which then also implies we have a diverging lens. Remember, just a property of diverging lenses, their focal length is negative, so it's divergent. And it's exactly the same as a concave lens. They're just two words for the same type of lens. Okay, again, pause the video and let's have a look at question 3. So it says the anther of the flower has a width of 0.2 millimeters. Okay, so again, just from repetition of questions, I can spot that that's going to be my object height is 0.2 millimeters. Okay, or my object size. The magnifying glass is placed 5 centimeters from the flower. So the flower being the object, the magnifying glass being the lens. Therefore, my object distance is going to be 5 centimeters. And an image of the anther is produced that is 3.5 millimeters wide. Again, so if it's an image is produced that's 3.5 millimeters wide, that must be my image height. Now it says calculate the power of the lens in the magnifying glass. Now, I'm not really sure what formula to use, so I'm just going to write down everything I know. So I know power is equal to 1 over F. And I know to get power, or to get focal length, I can use 1 over F equals 1 over U plus 1 over V. Okay, so in order to find power, I either need focal length or I need U and V. Okay, well, I'm given U in the question, but I'm also given object height and image height. So that's going to indicate to me that maybe I want to use the magnification formula, image height over object height. Okay, well, I also know for magnification, it's minus V over U. Again, the negative sign being important. Okay, well, looking at that, I can see that I've got my image height, I've got my object height. I've not got a V, but I have got a U. So I can use this formula to find V. So if I equate those two things together, this implies that image height over object height is equal to minus V over U. So to find V, if I times by U and divide by minus 1, I get V is equal to image height over object height times by U, and that's all negative. Again, let's not forget our negative signs. Okay, so replacing the letters in the formula with some numbers, I get that V is equal to 0.2 millimeters over, my image height, which is 3.5 millimeters over 0.2 millimeters multiplied by 5 centimeters. Now notice I've kept my units in, okay, and that's because millimeters and millimeters can cancel out. You can just multiply and cancel out units like you would normal numbers. So I'm left with V is equal to minus 87.5 centimeters. And notice I keep writing my units because I don't want to make a mistake there. Okay, well that's helpful. Now in my formula for power, I can see that I've got U, I've got V, so I can definitely find power. So my power is going to be equal to 1 over U plus 1 over V. Now let's not forget, we always need to convert to meters to use the power equation. So always convert to meters when using power equation. Okay, so power is going to be equal to 1 over, well, that's 0.05 meters, and that's minus 0.875 meters. So that's going to be 1 over 0.05 minus 1 over 0.875. So it's 1 over U plus 1 over V, but because we've got a negative sign, because a magnifying glass is going to produce a virtual image, which is why we get negative. And think about that for a sec. You can't project the image formed by a magnifying glass onto a screen, so it has to be virtual. So putting that into a calculator, I get 18.6 diopters. Now when I found my answer, I made sure to round to the highest degree of accuracy is given in the question. So you can see 1 decimal place, 1 decimal place, 1 decimal place. So that's the highest degree of accuracy in question.